Hi everybody, it's Mrs. Harbin and we're doing video notes 2.1, where are the electrons? So please read through these bullet points so you know what it is we're talking about in the video. You could write them down, you can make sure you can do them, you'll see them at the end. In the book, you're going to read sections 11.7 to 11.9. So read those pages, and at the end of the video there'll be some questions that'll connect you to the book. All right, so where are the electrons? We know where the protons and neutrons are. We know the electrons are in a cloud. So now we're going to describe that a little better. Each electron cloud has energy levels, and that's where you'll find the electrons. So the first energy level has what's called sublevel in it, and it only has one. It's called an S sublevel. So you can put 2 electrons in the first energy level. So that's really close to the nucleus. Okay, so this is a model of what I'm talking about. The second energy level has 2 sublevels, an S and a P sublevel. So you could put 2 electrons in the S and 6 electrons in the P. So it can hold up to 8 electrons, but then it's full. Then the third energy level is even bigger. It's further away from the nucleus, and there are 3 sublevels. And it's got an S, a P, and a D sublevel for a total of 9 sublevels. And then it could hold 18 electrons. Then there's a 4th energy level and a 5th and a 6th, and it goes on and on. So where are the electrons? We think they're in energy levels. Within those energy levels are sublevels, and within those sublevels are orbitals. And that's where the electrons are. So how do the electrons fit into these energy levels and sublevels? Well, there's some rules we have for describing it based on evidence. And so we can describe where the electrons are using orbital diagrams and electron configurations. Here's some rules that you need to follow if you're describing where electrons are in atoms. You fill the lowest energy sublevels first. An S sublevel can hold 2 electrons, P can hold 6, and D can hold 10. Only 2 electrons can fit in an orbital, and if they are in the orbital, they have to have opposite spins, and 1 electron goes in a sublevel until it's half filled before you double up. Okay, so here's a diagram of what the clouds look like when you superimpose them on top of each other. S's are spheres, first energy level, second energy level. P sublevel has orbitals that look like figure 8s kind of in 3 directions, and then another sphere, more figure 8s, and then all of these here, the D sublevel would be on top of that, and then the F sublevel when you get to the higher energy levels. Okay, so it's a cloud, but the cloud is described by probability sections of where you'll find electrons. So we represent where the electrons are in a couple of ways. One's called an orbital diagram. It uses circles or boxes to represent an orbital, and then arrows to represent electrons. So circles are orbitals, arrows are electrons. The lowest energy is the energy level, is the first energy level. It has an S orbital in it. And then, so it starts here, it's the lowest energy, and the amount of energy each sublevel has increases as you go up, as you can see the increasing energy. So what element are we representing here? Well, electrons are arrows. So there's 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 electrons. So you look on the periodic table, find out what has 19 protons, and then it's 19 electrons because elements are neutral. So this is potassium. Ooh, potassium. All right, how about this one? That's an I right there. So this is how the electrons are filling the sublevels and orbitals. There's 2, 4, 6, 8, 10, 12, 14, 15, 16 electrons, so it must have 16 protons. So that's sulfur. Yay, sulfur. So you can figure out what element you have by counting the number of arrows which represent electrons. Electron configurations is another way of describing where the electrons are, and instead of using boxes and arrows, it uses numbers and symbols. So here's an orbital diagram for sulfur. We would write that, I'm just going to put 16 there so I know how many protons. Then you would just translate, instead of saying 1s with a box with 2 arrows, you say 1s, and the 1s has 2 electrons in it, so you put a 2 there. It's read 1s2. 2s sublevels holding 2 electrons, 2s2. The 2p sublevels holding 6 electrons, 2p6. 3s sublevels holding 2, and the 3p sublevels holding 4. And that takes care of all 16 of sulfur's electrons and describes their location within the energy levels outside the nucleus. So this is called an electron configuration when you see numbers, letters, and more numbers. And it's read 1s2, 2s2, etc. So why does this have to be a 6? Because that's all that can fit in this P sublevel. This one's only 4 because sulfur only has 16 total, so it only needs to put 4. Okay, so how do you fill the orbitals? Well, you can memorize them, and I'm going to give you a trick with the periodic table. It's not a trick, it's a use. But you can also write this down. So if you're able to write this down, you're representing the energy levels and the sublevels within it, okay? And then these arrows show how they fill. So what fills first is the 1s sublevel in the first energy level, and then the 2s sublevel in the second energy level. After that's full, if there are more electrons, they'll go into the 2p sublevel, 3s sublevel, and then the 3p sublevel, 4s sublevel, and then 3d, 4p, 5s. So you draw your arrows on a diagonal, and then if you follow the arrow, once you get to the arrow point, you come back to the bottom again and fill it. So I draw it this way so you can see the electrons going in to higher energy levels as they go. You'll see it different ways, but that's one way. If you can draw this, which I recommend doing, then you have the orbital filling order. Okay, so let's practice. Let's do the electron configuration for sodium. So I look up on periodic table, sodium. It's got 11 protons, so I need 11 electrons. Start here, and I say 1s, and I know that s can hold 2, p can hold 6, d can hold 10. F can hold 14. That's the maximum. Okay. So 1s2, that takes care of the first 2 electrons. Then I go here. 2s2. All right, so I'm here. So I'm going to go back down to here. And now I'm at 2p. And I could, sodium could put 6 electrons into the 2p sublevel. And then 3s1. And I stop there because that's 2, 4, 10, 11 electrons. And so that represents sodium. Now, ions are different because remember, ions are formed by losing or gaining electrons. So I'm going to tell you right now that sodium makes a +1 ion. So what does that mean? Well, it starts out with 11 protons, always, always, always for sodium, and 11 electrons. But it loses 1 electron to make an ion, so it only has 10 electrons and 11 protons in order to make that ion. So instead of going for 11 electrons, I'm going to go for 10 because sodium ions only have 10 outer electrons. 10 total electrons. Sodium atoms have 11. Okay. Potassium atoms. So atoms are neutral. So you put the symbol. I put the potassium's atomic number down there so I remember. 19 protons is 19 electrons because it's neutral. So now I have to find a place for all those electrons. Start at the bottom, 1s2. That fills up, so they go back to here. 2s2, because s can only hold 2. 2p6. 3s2. And then back to here. 3p6. And then 4s1. And then I've got, I'm just adding up 10, 18, 19. 19 total electrons. So atoms are neutral, so protons equal electrons. Ions have charge, and we'll get to know what charges things make. Okay, so this filling diagram works. You just got to draw it and follow it, or you can use the periodic table. This form of the periodic table looks a little different than you've ever seen probably, but if you follow along, going from here to here is where you're filling the S sublevel, 1s. Then you're going to the next atom, which has 3 electrons, so then you have to start in the 2s sublevel, and then you fill it up, 2s1, 2s2, until you're here, and so then you have to start here again. When you go over to the periodic table here, you're in the second energy level, so let me just put some numbers here. You're in the second energy level, that's what this 2 stands for, and you're filling the 2p sublevel that could hold 1, 2, 3, 4, 5, 6 electrons. And so by the time you get to here, this is neon, this is element number 10, atomic number 10, then you've filled up 1s2, 2s2, 2p6, and that's 1s2, 2s2, 2p6, we got to neon. All right, so let's try another one. Let's do tin, okay? So let's do tin is Sn, and you probably see yourself, so where's tin? Let's see tin. Yeah, so that's what we're doing with tin. And it has atomic number 50. All right, so we have to get way down to 10, which is 50, which is right. Let's see. We have to get to here. 50. All right. So we can go on that, or we can follow periodic table. 1s2 right there, 2s2, 2p6. Now I'm in the third energy level, third row. 3s2, over here is 3p6. And then I've gotten to 18, which is argon, and then I'm at 4s2. Notice here, 3d10. So be careful, because you notice after 4s, you fill 3d. And then there, 4p6, you get to here. And I can check, I'm at 36, and this is element 36. Then I can go to, it's this continuation, 5s2 over here, 4d10, right? And then we're back to 5p, 1, 2. Okay, so in order to show the electron configuration for tin, I got to show 50 electrons. I have to fill it up going in order, and I could use a filling diagram, which you can see the numbers change. It goes from 3p to 4s and back to 3d. You could also look at the periodic table. After 3p comes 4s and back to 3d and then back to 4p. So you can start to use the periodic table instead of this to do it. But you might be saying to yourself, Self, is there a shorter way to do this? Okay, there is. So I just taught you electron configurations and orbital diagrams the long way, and now the short way is what is called a noble gas electron configuration. So noble gases are group 18, right here, noble gases. Noble gases. And noble gases don't form bonds with other elements because they are stable. So they have full valence shells, a full set of electrons that they don't want to make bonds with because they don't need to. Okay. So since they're stable and don't react, we can use them as like the stable part of our element and then continue on from there. Here's what I mean. We just did 10, right? So 10 was 50. I'm going to go back to the slide before. So we had to get to 5p2, which is right here. The noble gas that comes before 10 is in this column, and it's element 36, which is krypton. Right? Krypton is a noble gas that's non-reactive, so its electron configuration is stable, and that takes care of the first 36 electrons. So we're at just 10, 20, 36. So this whole part right here is krypton's electron configuration. So I could put brackets, has to be brackets, symbol Kr for krypton. And I've just done all of the electrons for krypton. So 36 electrons have been taken care of from that. So here's krypton right here. So then I go to the next row on the periodic table, which after krypton comes row 5, element 37. So over here is called the S block. So I'm going to put 5S, because the S orbitals go here too. And I'm at 36, 37, 38. And then this is 4D, because the D block is one number lower. And then to get to 10, I've got 5P2. All right. So noble gas is a shorter way to do it. You have to use a noble gas that comes before your element. Okay, let's talk about germanium. Germanium symbol is Ge. It's got 32 electrons. All right, let's see where germanium is. It's right here, 32. So I find a noble gas that comes before. So this is 32 electrons. I gotta use argon, which has 18 electrons. So I've done all the electron configuration up to argon, and I put that bracket there. So then I go after argon, I'm at 19 is potassium. So then I'm at 4. How do I know it's 4? Because I have 4s. 2 electrons could fit there. This is 3d, and 10 electrons could fit there. And germanium's over there, so it's 4p2. Okay, so that's the short way to do it. We'll practice it. All right. Another couple things. Valence electrons. These are outermost electrons. Write this down. Valence electron definition. They're the highest energy S and P electrons. Highest energy level S and P electrons. So I wrote out chlorine's electron configuration. How do I find the valence electrons? I find the highest energy level. 3 is the highest energy level represented in this electron configuration. And then I add the S plus the 3p electrons together. So I got 2 7 valence electrons for chlorine. Okay, chlorine has 7 valence electrons. All right, we'll talk about what that means in a second. Calcium. How do I find valence electrons? I find the highest energy level, 1, 2, 3, 4. 4 is the highest energy level represented with calcium. So then I find 4s plus 4p, and there's only 2 there, 0 there. 2 valence electrons for calcium. Calcium has 2 valence electrons. Okay, let's try nickel. All right, so I find the highest energy level representing. So I look at the big numbers. 1, 2, 3, 4, 5. So 4 is the highest energy level. 4, and I add up the 4s plus the 4p, and there's only 2. So 2 valence electrons for nickel. That's how you find valence electrons. You look at the electron configuration, you find the highest energy level that element utilizes to put its electrons, and you add up the s plus the p. Okay. So valence electrons help you determine charge and how bonds are going to form. All right. So 8 is the target number for most atoms. So another thing you can do is you're going to find out that group 1A, 2A, 8A, 7A, 6A, 5A, 4A. So I took the tall groups and I labeled them A. Their number of valence electrons matches their A number. 2, 3, 4, 5, 6, 7, 8. We just did valence electrons for calcium. We found out it had 2. Well, that happens for every element in the same rows, in the same column as calcium. We did, what other one did we do? Oh, chlorine. We did chlorine's valence electrons. Here's chlorine at 7 valence electrons. Every element in this column has 7 valence electrons. So what elements are going to do is they're going to lose or gain electrons or share them to get 8. So what chlorine is going to do, it has 7 valence electrons, it's going to gain 1, so then it has 8 valence electrons when it bonds. Okay. So ions that form because atoms lose or gain electrons, and their valence electrons are the electrons that are lost or gained. So we said chlorine had 7 valence electrons, right? Look at this. But if you put one more valence electron, you fill out that outer shell for chlorine. So chlorine ion is going to be 1s2, 2s2, 2p6, 3s2, 3p6. So it's 1 extra valence electron as an ion. Woohoo! So now it has a total of 8 valence electrons. Let's see what happens to calcium. Okay, calcium, we already said, has 2 valence electrons. So we went to the highest energy level and we got 2. So what calcium is going to do, it's going to make a +2 ion because it's going to go 1s2, 2s2, 2p6, 3s2, 3p6, and stop there because these 2 electrons are going to go away. They're going to be given away to another element, another atom, so that calcium has a +2 charge. But look what that means. That means its outer energy level is filled with 8. So metals, losers, because then their outer shell is full. Okay, nickel had 2 valence electrons. Nickel's going to make a +2 ion. 1s2, 2s2, 2p6, 3s2, 3p6, 3d8. And you're saying to yourself, Harbin missed something. Right. These 2 electrons are going to be the ones that nickel's going to lose to make a +2 ion. We're not going to memorize charges for transition metals like nickel because it could vary. So we'll talk about that too. Let's play what element am I? So if these are elements, then protons equal electrons. So we can add them up. We've got 10, 18, 19. This is potassium. All right, so we have 10, 18, 19, 20. This is calcium. Yay. Okay. What ion am I? If we start with this, we start with fluorine, which has 9 total valence electrons. Over here, there's 10, so it's fluorine, so it has 9 protons, and now it has an extra valence electron, so we have to put charge because it's got 1 extra electron. Okay, so that's a fluoride ion. Fluoride. All right, again there. There's exceptions always. So we just learned electron configurations, orbital diagrams, ions that form. There are some exceptions. And some elements, and we'll talk about them in class, instead of filling up an orbital, we'll put some electrons in one and some in another so that everything's half filled or one's completely filled because that's more stable than it would be otherwise. Okay. So for instance, well, we'll talk about it in class, but silver, I'm going to do short configuration. And we have 36. And then 5s, 1, 4d10. You might be saying to yourself, wait a second, silver should have 5s2, 4d9. But that's not what we see. This is silver's electron configuration. Okay. Chromium has some similarities to that. So let's just say chromium. It should be argon, and then 4s2, 3d4. But that's not what we see. What we really see is 4s1, 3d5, because then each of those is half-filled, and that's more stable. Okay, so groups 3 to 12 on the periodic table can form more than one ion. So here's titanium's electron configuration. Titanium is right. So what kind of ion will titanium form? Well, first let's find valence electrons. Its highest energy level is 4. 4s plus 4p equals 2, right? So that's 2 valence electrons. So if titanium loses that 2, it becomes a titanium plus 2 ion, and those are gone. Titanium could be a plus 4 ion if it loses those 2 and loses those 2 in the d orbital. So transition metals, these ones in the middle, they don't have charges you can memorize. There's some that we will, but it can have multiple ions because it can lose its valence electrons, sometimes, and maybe some d electrons to make ions. So, to make ions. So, transition metals, groups 3 to 12, have multiple charges. But other groups only have one charge. Okay, but they're all going to be ions that lose, so they're always going to be positive. Okay. Lots of stuff going on there. Hopefully you got the gist of it, but now I want you to try these. Okay, please put these into your notes, and you can ask about them in class. Right? Here's a review. So electron configurations are periodic, so use your periodic table to help you use the rules to fill them up. Valence electrons are almost S&P. They're used for bonding, and then we can figure out how atoms form ions. All right, here's some of the things you're supposed to learn. We'll talk in class. Peace out.